Hi guys, welcome back to my channel. So today we are going to discuss about topic 7 PSPM 2013 and 2014 question. So as we can look at the question, so figure 3 above shows a beam executing a cipher harmonic motion with a period of 1.8 seconds along a straight line between point X and Y, which are 25 cm apart. Point O is a midpoint between X and Y. So there's actually two info here. First is the period. Period is 1.8 seconds, and the second one is the midpoint. Actually, midpoint they mean here, they want to tell you that O is actually the equilibrium position. Okay, so the first Roman question, write an equation for the displacement for the beam. Equation, when they want you to write the equation, we need to know about the general formula first. It's actually for displacement is y equals to a sine omega t. Okay, so now our goal is to find a, the amplitude, and also omega. So as they already gave us the equilibrium position is O, so actually amplitude is actually the y here, amplitude, and also here. So this one is positive, this is negative, depends on the direction. If you want to consider this one as positive, the x as positive also can. So the amplitude is actually the maximum displacement from the equilibrium position. That's why actually this one is actually the magnitude. Then how can we find this? It's actually just amplitude is equals to 25, the total length, divided by 2, which is 12.5 centimeter. So while the omega, we know that normally when the question give you period or frequency, you can find the omega already, because omega is equals to 2 pi over t, right? So omega is equals to 2 pi over t. They give us the period, which is 1.8, so we can find it's actually 3.491 radian per second. Okay, so we just put it inside, sub into the general formula. A is equals to 12.5, the amplitude sine omega is equals to 3.491 and t, and there you go. This is the equation. And but don't forget to write the statement, which is where y is in cm, amplitude is in cm also, and also the time is in second. And that's it, our first answer. So the second question, calculate the magnitude of acceleration and velocity of the beam at point P. Point P is actually here. Okay, and they want us to find the magnitude only. First of all, we need to know the formula for the acceleration. Acceleration actually is A equals to omega square y. Okay, so we need omega, we already got it, and y, we need to find y. So y is actually not the 5 cm. They want to trick us, but actually y is actually from the equilibrium position to the P. So actually it's right here. This is the y. That's why actually y is equals to 12.5 minus 5 is actually 7.5. Okay, so we just sub everything inside. Omega is 3.491 square, and the y displacement is 7.5, and we just press our calculator and you'll get 91.4 cm per second square. Okay, so for the velocity, we also need to know the formula. Velocity is equals to omega square root amplitude square minus displacement square. So we just sub everything inside. As you all know, 3.491 square root acceleration is amplitude is 12.5 square displacement is 7.5 square, and if you press your calculator you'll get 34.91, and remember the unit cm because the amplitude is in cm, seconds per second. Okay, so the third question, calculate the position along x and y where the kinetic energy is equal and the potential energy of the beam are equal. So we just write it out, kinetic energy is equal to the potential energy. Okay, then we also need to know the formula. Kinetic energy is 1/2 m omega square bracket a square minus y square, while the potential energy is 1/2 m omega square y square. So as we can see, there's the same thing, we can just cancel it off, cancel the m, cancel the omega square. So we are just left with a square equals minus y square equals to y square. We just move it around, and because they want us to find the position is actually they want to find y, so y, just move it around, so y square is actually equals to a square divided by 2, y is equals to plus minus square root of the whole thing, a square over 2. Okay, as we all know that the a amplitude is 12.5 square and 2, so we just use our calculator. It's actually y is equals to plus minus 8.839 cm in centimeter. So actually the position where the kinetic energy and potential energy is the same is around here and here, which is 8.839 centimeter. Okay, so now we just go to the next question. A vertical spring extend by 3 cm along when a 100 gram mass is suspended at its end. So there's also two information, as we all know that this one is the extension x and this one is the gram, so we just change it to kg first, the SI unit is 0.1 kg. So the question is, calculate the period of oscillation of the spring when the mass of 150 gram is added to the system. Okay, so first of all, we know that the period of oscillation of the spring is the formula is actually T, the period is equals to 2 pi square root m over k. So where m is actually the mass and the k is actually the spring constant. So how can we find that? So they already give us the extension of the spring, so actually there's a formula called F equals to kx. Okay, so we have the force, so actually we can draw the whole thing first. The spring, so it's like a spring, then there's a mass here, 100 gram, so we just change it to the kg first as a unit, 0.1 kg. Okay, and it extends 3 cm. Okay, so we just put it, we can find the force actually, because this one is the weight, right? Weight here, so weight, we want to find the force. Actually force is actually 0.1 times the 9.81 to find the weight, which is also the force. And then k is equals here, and the x is actually 3 cm, so we also need to use SI unit, so 3 times 10 minus 2 exponent 2. Okay, so k is actually use your calculator, is 32.7. okay, So we can use can do this already. So actually t 2 pi. Now this time the mass is actually the question is asked if the mass is changed to 150 gram. So 150 gram is actually 0. Is added, sorry, pardon me. So it's added, so not changed. So it's added. So it's actually 0.1 plus 0.15 is actually 0.25. And the spring constant will not change, so it's constant, right? So it's also the same, 32.7. Eventually we'll find the answer is 0.549 second. Okay, we got the answer. So last question is, if the spring with the same load is allowed to oscillate horizontally. Just now the question is vertically, right? So horizontally on a frictionless surface, will the period decrease, same, or increase? So actually the answer is will be same, because it is a frictional surface. That's why it will be the same. Thank you.